Okay, good evening. Welcome to Math Project, or Math for Kids. What are we doing these days? Math for Kids. Number?
79.
79. Okay, I gotta draw a line across the bottom here. Alright, you ready for the problem?
Yep.
Okay, here we go. Suppose you have 4 coins with values 1 cent, 5 cents, 10 cents, and 25 cents. Using at least 1 coin each time, how many different amounts of money can you make? Okay, do you understand the problem?
Yeah.
Okay? Actually, there's a really cool way to do this problem using counting in binary, but that's for a different day. Remember counting in binary?
Yeah.
Okay. But we won't talk about that today. How would you like to do this problem?
I'd like to make a chart.
A chart. Okay, let's make a chart. 1, 2, 3, 4, 5, 6. Let's squeeze this in. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. No, hopefully that'll be enough. Okay, and if you're going to make a chart, how would you like to start counting them?
Well, first, let's do the ones with only one.
Okay.
One coin, and the ones with only 2 coins, and the ones with only 3, and the ones with only 4.
Okay, well that will be interesting. Alright, well what are the different ways we can use 1 coin?
Well, you can just use 1 cent,
Okay.
5 cents.
And what does 1 cent add up to?
1 cent.
Okay, good. So this is 1 cent, which equals 1 cent. What's the next one?
5 cents.
5 cents, great. And what does that equal?
That equals 5 cents.
5 cents, very good. And what's next?
10 cents.
10 cents? What does that equal?
Was 10 cents.
10 cents. So the thing you got to be careful of if anything ever equals one of these. Okay? And we can do one more with 1 coin, which
25
is
cents equals
25 cents. Okay? Alright. Alright, now we got to do the ones with 2 points.
We do 1 cent plus 5 cents.
1 cent plus 5 cents. I'm going to stop writing the cent sign, okay? So 1 cent plus 5 cents equals?
6 cents.
Have we used 6 cents before?
No.
Okay. What is next? Now this is the most important step. What's the next thing to do?
Let's do all the values with 1 cent first.
Very good. All the values with 1 cent first.
So 1 cent plus 10 cents.
1 cent plus 10 cents. What does this equal?
It's 11.
11. Okay. What's next?
So it's going to be 1 cent plus 25 cents.
1 plus 25, which is?
Which is 26.
26. Very good. Is that all the ones with 1 cent?
Yep.
Okay. Now what do you want to do next?
Now we start with 5 cents. What I have to do? It's 5 cents and 10 cents plus 5.
Okay. Why don't you do 5 cents and 1 cent?
Because you've already used it.
You already used it. Okay, great. So 5 plus 10, which is?
15.
Okay, we got to double check. We're not. Have we ever used 15 before?
Nope.
Nope. Okay. What's next?
5 plus 25 is 30.
Yeah.
We haven't used 30.
Haven't used that before. Okay. And
now the ones with 10 cents.
okay.
It's only 10 plus 25.
10 plus 25.
35.
Which is 35. Very good.
And now with 25 cents, we've already used all the possibilities.
We've already used all the possibilities. Okay, great. Now we're gonna do the ones where we use 3. Okay?
Let's do it to 1 cent first again.
Okay, so we're gonna do 1 plus
5 plus 10.
1 plus 5 plus 10, which is?
Which is 16.
Okay, 16.
We haven't used 16.
We haven't used 16 before. 16, okay. What do you want to do next?
1 cent plus 10 cents plus 25 cents.
Okay. Be careful when you're counting these. 1 plus 10 plus 25 is?
Is 36.
36, okay. Are there any more with 1 cent?
1 cent plus 5 cents plus 25 cents.
Okay, good. So it might be good to do 1 cent, 5 cent, 25 after this one, but you didn't miss it. 1 plus 5 plus 25, which is
31.
31, okay. And again, I don't see a 31. Okay, so that's very good. So what do you want to do next?
Now the ones with 4. Now I have to do the ones starting with 5 cents.
Okay. 5.
5, 10, and 25.
5 plus 10 plus 25.
And we can't include a 1 cent in there because we already used it.
Okay, so what does that add up to?
That's 40.
40.
And we haven't used it.
Okay, we haven't used it. So here's the interesting thing. There were 4 where we had 1. There were actually 6 where we had 2. 1, 2, 3, 4, 5, 6.
Yeah.
So far we've got 4 where we had 3. Now are there any more where we use 3?
Well, no.
Okay. And here's why. If you're going to pick 3 of these, you're always going to leave 1 out.
Yeah.
Okay, and only 1 gets left out. So you look at the ones where you leave out 1, you look at the one where you leave out 5, look at the one where you leave out 10, look at the one where you leave out 25. And that's all of them. Okay, so there's also 4 of those. Now what about the ones where we use all 4?
There's only 1.
There's only 1. 1 plus 5 plus 10 plus 25. What does that add up to, by the way?
Well, it's 41.
How do you know?
Because this is 40.
That's 40 and we just added 1. Okay, 41. So there are 15 of them. Okay, and you do have to be careful on how you count this because you got to make sure that you don't
miss any.
So it goes, the number with 0 is 1. There's one choice that has 0 of them. What choice is that?
It says using at least 1
Right.
coin.
Right. But if you pick none of them, that's one choice that uses 0, but we can't do that one. We got 4 that use 1, 6 that use 2, 4 that use 3,
and the one that uses
and 1 that uses 4. So there's actually that. Oops, sorry. And 1 that uses 4. Okay, and that makes 15 of them. So there's 15 choices. Okay, and there's a couple different ways to think through this. One involves counting in binary. The other way involves counting with Pascal's triangle. Remember talking about Pascal's triangle?
Yeah.
Yeah, so we got a lot of, actually this problem leads a lot of interesting places. Anyway, so the answer is 15. Good?
Yep.
High five. Good job. Good job, Henry.